I bought this repossessed Bugatti Veyron with supposedly a broken gearbox. Nothing happens, but we managed to solve the problem with just a tiny fuse.
Matt Armstrong's Bugatti Veyron has become one of the most talked about rebuilds in the automotive world right now, and for good reason. This car arrived with a dead gearbox, a persistent engine misfire, and a coolant leak that had been dripping onto the garage floor since day one. It was fixed just enough to finally move under its own power. And the moment it did, it made clear that the obvious problems were never the real ones. Every repair on this Veyron keeps pulling back another layer. Underneath each fix is something worse waiting to be found. Right now, Matt is dealing with a hydraulic pump that ran itself into the ground, wiring so badly cooked it was crumbling apart in their hands, a misfire that appears and disappears without explanation, and a gearbox pump that stuck on during its very first drive and nearly destroyed itself before anyone could stop it. What's being uncovered inside this car is only getting worse, so let's go through exactly what happened. The gearbox investigation started with what looked like good news. Matt brought in Ricky from our performance to remotely assess the hydraulic pressure system. On a Veyron, the gearbox doesn't shift like a conventional automatic. It uses a pump that builds hydraulic pressure, stores it inside accumulators, and then releases it in precise bursts to execute each gear change. The system should build to around 50 bar, hold that pressure, and only bring the pump back on when it drops below 44 bar. In a healthy car, that cycle takes roughly 2 minutes between pump activations. Ricky asked Matt to cycle through the gears while monitoring how long the pressure held before the pump restarted. The result was better than expected. The accumulators were holding well, and the gearbox itself appeared to be in good health. On paper, everything looked fine. But Ricky flagged something that couldn't be ignored. A melted fuse had caused the original gearbox failure, and a fuse doesn't melt unless something in the circuit has been drawing too much current for too long. The gearbox looked healthy, but whatever had destroyed that fuse was still in the car somewhere, unidentified, waiting to cause the next failure. Attention shifted back to the engine misfire. The Veyron's W16 is essentially two 8-cylinder engines sharing a common crankshaft, split into a left bank and a right bank, each controlled by its own ion control module. These modules monitor combustion inside each cylinder and control the coil packs that fire the spark plugs. Diagnostics pointed towards cylinder 16 on the left bank, with random misfires appearing across that entire side of the engine. Matt's first step was to swap the coil pack from cylinder 16 to cylinder 15, clear the fault codes, and restart the engine. The logic is straightforward. If the misfire moves with the coil pack is the problem. If it stays on cylinder 16, something else is causing it. Getting to those coil packs is not straightforward. It required removing the quarter panel, the air filter housing, coolant pipes, the charge cooler, and a supporting structural frame, just to reach components that, on most cars, take minutes to access. This is part of why Bugatti charges over $20,000 for a standard service. The labor isn't padding. The car genuinely requires that level of disassembly for routine maintenance. After everything was reassembled and the engine restarted, cylinder 16 was still misfiring. The coil pack wasn't the problem. But then something shifted. The misfire didn't stay on cylinder 16, it spread. Cylinders 9, 10, 11, 12, 13, 14, and 16 all began misfiring simultaneously. The entire left bank. The right bank remained completely clean. That pattern points to one component, the ion control module for the left bank. If that module fails, every cylinder it controls begins to misfire at once, while the opposite bank continues running normally. A replacement costs around $9,000, and Bugatti technicians had already encountered the same failure on at least one other Veyron. Matt swapped both modules between banks, cleared the codes, and restarted the engine. The faults disappeared, but he wasn't ready to call it fixed. The misfire had been behaving strangely throughout, aggressive on cold starts, then fading once the engine reached operating temperature. Nothing had been repaired. Components had been moved around, and the problem had temporarily gone quiet. That's not the same thing. Then the gearbox pump wiring stopped the garage completely. When the pump was pulled, what they found looked like something from a fire investigation. The wiring insulation wasn't just worn, It was brittle, crumbling, and had been cooked to the point where exposed copper conductor was visible along the wire. One of the team said they had never seen wiring destroyed like that on any car. This was an age. Wiring insulation doesn't fail this way from time alone. It fails from sustained, extreme heat, the kind generated by a pump that has been working far harder and far longer than it was ever designed to. This was the real reason the fuse kept blowing. The pump had been generating so much heat that it eventually destroyed its own wiring, and the fuse was simply absorbing the overload until it couldn't anymore. What made it even harder to accept was what the pump actually is. The hydraulic pump responsible for operating the gearbox in a $1.5 million Bugatti Veyron is the exact same pump used to raise and lower the soft-top roof on an Audi A5 convertible. A component built for occasional, low-frequency use is running continuously in one of the most demanding environments a pump can be placed in, activating every time a door opens, every time pressure drops, every time a gear is selected. Bugatti reportedly replaces these pumps as part of annual servicing because they already know how vulnerable they are. This Veyron had almost certainly gone years without that service being done. A replacement pump was ordered. The damaged wiring was temporarily wrapped to prevent short circuits, and testing continued. The cooling system had been waiting for attention since the car first arrived. Coolant had been leaking onto the garage floor from the beginning, and finding the source meant removing the wipers, the bonnet, the front bumper, the headlights, and both front wings. Even after stripping the front end that far, the radiator was still buried behind cooling fans, carbon fiber panels, and structural components bolted directly to the chassis. Fully extracting it would have meant dismantling the front suspension, the steering rack, and the subframe, a job measured in days, not hours. A smoke test was used instead, pressurizing the cooling system and looking for where it escaped. It found a tiny pinhole leak, most likely caused by a stone strike at some point in the car's history. Matt used a radiator sealant formulated to circulate through the system, locate the leak internally, and cure into a permanent seal. Because the Veyron's charge cooling circuit doesn't connect to the cabin heater, the risk of sealant causing damage elsewhere in the system was low enough to justify the approach. The engine came up to temperature, and the leak stopped. With the coolant sealed, fuel added, fuse replaced, and codes cleared, Matt Armstrong was finally ready to drive it. Reverse engaged cleanly. Drive selected without hesitation. The W16 delivered torque that felt almost absurd at low speed. Seamless, relentless, completely effortless. The sound alone brought people out of nearby buildings to see what was making it. For the first time since arriving at the workshop, a Bugatti Veyron that had been completely immobile was moving under its own power. Then every warning light on the dashboard came on at once. Transmission warning. Engine light. And from behind the seats, the gearbox pump wasn't cycling. It was running continuously. Pressure climbed past 50 bar, past 60, pushing toward 72. Matt understood immediately what was happening. The pump was stuck on, commanding itself to keep building pressure with nothing telling it to stop. If it wasn't shut down quickly, it would destroy itself. The only option was pulling the fuse. The moment it was disconnected, pressure dropped, the system reset, and the car drove normally, as though nothing had happened at all. A relay, a pressure sensor, or a fault buried somewhere in the gearbox control system was almost certainly commanding the pump to run without ever sending the signal to stop. Not consistently enough to throw a clean fault code, but persistently enough to overheat the wiring and blow fuses until the system finally failed completely. The root cause was still unknown. At this point, Matt committed to a full service. If degraded fluids were contributing to the faults, and everything suggested they were, proper diagnosis would be impossible without first eliminating that variable. All 16 spark plugs were removed. Every one of them was heavily carboned up and long overdue for replacement. The gearbox oil looked surprisingly clean, suggesting the transmission may have been serviced independently at some point. But the engine oil told a different story entirely. The W16 has 16 individual drain points underneath the block, and what poured out was dark, heavily contaminated, and showed no sign of having been changed in thousands of miles. The oil filter was worse, discolored and visibly damaged by heat. Throughout the entire misfire investigation, this engine had likely been running on oil that was well past the point of offering any real protection. The front Haldex unit was drained. Filters and components were cross-referenced through third-party suppliers because Bugatti refuses to supply individual parts outside of authorized dealerships, making independent servicing on this car intentionally difficult at every step. The Veyron now drives. The gearbox shifts. The engine makes power, but the pump fault has no confirmed cause, and the misfire has no confirmed fix. Somewhere inside this car's electrical system, something is still hiding, and the next time this Bugatti is pushed under real load, everything it's been concealing may surface all at once.